Sounds good. So this is where we stopped yesterday graphing these inequalities or these set builder notations on a number line. So if we look at the first one, for all real values of x, brace x bar, for all real values of x, such that, or sorry, the set of all real numbers x such that -6 is less than x is less than or equal to -2. Now we do have two endpoints, which are -6 and -2. So we have the 2 points. We need to see if they are going to be opened or closed, if they're going to be equal to one of those two values, both or none. So would we fill in the spot at -6? No, because it's telling us -6 is just less than x, not equal to. So it's going to be open. How about -2? It's going to be closed because it is going to be equal to it. Now we need to finish shading this line. We would shade in the middle. Since x is in the middle, we're going to shade in the middle because it's going to be between -6 and -2. That's it. Number 5, for all real for all real numbers x, such that x is less than or equal to 0 or x is greater than or equal to 10. How many points are we going to have on this number line? 2. 0 and 10. 2 key points. 0, is it circled to be opened or closed? Closed, because it is indeed equal to it. How about the 10? Closed, because it is indeed equal to 10. Now we just need to shade. Do we shade in the middle? No. X is what? Less than or equal to 0, so we would shade to the left. And 10, we would shade to the right. And that's it. Questions on this here? Write the set of numbers in set builder notation. So the two things we need is the type of numbers we're talking about, because that's going to go in front of our bar, our such that, and the description telling us more information about the types of numbers we're talking about goes after it. So let's look at this first one, the set of all integers. So the type of numbers or our set of numbers we're talking about are going to be integers. And our description is what? Greater than 5. Now the description we're going to have to rewrite as an inequality. So we're talking about x. Our values of x, our numbers, these integers have to be what? Greater than what? 5. So we're saying that x has to be greater than 5. So that's our inequality. So that they give it to us as an interval, like the next one, we have to have it as an inequality. If they give it to us in words, we're going to need it in an inequality. The only time we won't is if we are able to describe the set easily or nicely with numbers. Like referring back to 2 days ago when we were talking about the whole numbers less than 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can list those. We don't need set builder notation. But when here we're talking about all the numbers greater than 5, all the integers greater than 5, it's not going to be really doable to try to write them all out. So we're going to use set builder. So let's start writing this in set builder notation. So we'd have our brace x. Now if x is our in the real numbers, or we're talking about all the real numbers, we're going to go brace x bar. But are we talking about the real numbers? No, we're saying that it is a what? Integer. So we can say x is in the integers, x is an element of the integers, such that what? X is greater than 5. X is in the integers such that x is greater than 5. X is an element of the integers such that x is greater than 5. Questions on this here? And there are other ways to write this. we could say the set of all real numbers x such that x is an element of the integers and x is greater than 5. It is saying the same thing, it's just a few more words, few more symbols, but we do get the same statement. Now the textbook, Big Ideas, does this a little bit differently, and I really don't like this. X is, for all real numbers x, such that x is an integer and x is greater than. That's a whole lot of writing just to say the same thing as the top two. Make sense? We don't need all of them, we just need one of them. Many different ways to write it, all are saying the same thing. Questions on A? We're ready to look at B. So we have from negative infinity to negative 1 or negative 1 to infinity. They gave us intervals. Now this one here, they did not directly tell us what number types we're talking about. They didn't directly tell us the real numbers, the integers, the rational numbers, the irrational. But whenever we're given an interval, we're talking about the real numbers. Because we're talking about all the numbers between negative 1 and infinity, negative infinity, or negative 1 to infinity. We're covering that whole range. So it has to be all real numbers. Now we do need to change these to inequalities. Now there's different ways we can go with this here. We can go from the interval notation straight to inequalities. We could try to graph it. But if we're looking at this here, we're saying we want all the numbers from negative 1 to negative infinity. We want all the numbers less than what? Negative 1, yes? So the values of x are our values that make this statement true. This x has to be what? Less than negative 1, because we're talking about all the numbers from negative 1 to negative 15. Negative infinity, not 15. Negative 1 to negative infinity. We're going from negative 1, everything less than it. Because where is it heading? It's heading to negative infinity. It's getting smaller and smaller. So as long as x is less than negative 1, that statement is true. Now, can it be equal to negative 1? No, because in interval notation, if we have a parentheses next to our number, it's not included. Let's look at the other statement. We have negative 1 to infinity. We're also saying that x can be any number, what? Bigger than negative 1, yes? So for here, we'd have x is what? Greater than negative 1. Because we're saying it's also anything bigger than negative 1. Questions on how we got our two inequalities? Do you feel comfortable with these two here? Now we do need a word between them. Or. Because it was or before, it's going to stay or now. So we feel comfortable with how we got the inequalities, yes? Now all we're missing is the set builder notation, yes? Well, we have the inequality already written, yes? This is our description, and it's everything that comes after the bar, yes? All we have to do is add the fact that we're talking about the set of all real numbers, brace x bar, the set of all real numbers x, such that x is less than negative 1 or x is greater than negative 1. Are we missing anything? Brace it, brace, bracket at the end. Yep. That's it. Questions on how we wrote that out there? What's funny is there's actually an easier way to write this. It'll make sense once we look at it graphically. If I graph this, let's look at the first statement. Because our first one says that x is less than negative 1, yes? So negative 1 would be an open circle, and we would shade to the left, yes? Well, hey, the other equation is also, the other inequality is also referencing -1. And it's all the numbers bigger than it, yes? Oh, wait a minute. What is that telling us? It's telling us that x cannot be what? -1. X could be any real number except -1. Didn't we have something like this the other day? We could also say this is the set of all real numbers x such that what? X is not equal to -1. Because we said x is less than -1, and or x is greater than -1. Only thing it can't be is -1. Those say the exact same thing. If you don't notice the fact that we could condense it down to the second statement and give me the first, that's still right. That's still the right answer. If we see that we can rewrite it as the second one, that's still right. Yeah, both of those work. Questions on this here? We ready for the next one? Number 6, -infinity to -1, or 1 to infinity. Again, we're talking about two intervals, so that means we're talking about the set of all real numbers. And unfortunately, we can't just stick this in the set builder notation. We have to rewrite these as inequalities. Now, if they had given us an inequality to start with, they said write set builder notation for x is greater than 4. Well, we can say bracket brace x bar x greater than 4, brace. Because if it's already in an interval notation, we can just throw it in, we're good. Here, we've got to change these over. So the first statement here is saying that we want all the values of x less than -1 for sure, yes? But can it be equal to -1? Well, if it is equal to, we have to look at the symbol after it. If it's a parenthesis or a bracket. Parentheses means not equal to. Bracket means equal to. So since it is a bracket after -1, we do have to put equal to. The bracket says it's included. Parentheses says it's not. So we're saying x is less than or equal to -1. Now we still have our or statement, or 1 to infinity. What would this one be here? X is what? Greater than 1, because we're talking about all the numbers from 1 to infinity, all the numbers that are bigger than 1. Now, can we say that it is equal to 1? No, because the symbol next to our 1 is a parenthesis. Parentheses means it's not going to be equal to 1. It's just going to be greater than. What is the only thing we're missing at this point? Well, our set builder notation, yes? And since it is an interval, in the interval we'll have brace x bar, the set of all real numbers x, such that x is less than or equal to -1, or x is greater than 1. And that's it. Questions on this here? We ready for problem number 7? The set of all integers except -4. So this here is saying that our set type, our group of numbers that we're talking about, are the integers. And our description says that it is except -4. We have everything but -4, yes? Well, except -4, that means that x cannot equal what? -4. Okay. Brace x. Well, x is a part of the integers, so we can say brace x, element of the integers. X is an element of the integers such that x is not equal to -4. For all x's in the integers such that x is not equal to -4. For all values of x in the integers such that x is not equal to -4. Questions on this here? Questions on anything we've done so far? The last three problems, we can write these in set builder notation or just write the set out. Now the whole number is 50 through 54. So what would be our first whole number with 50 through 54? Well, it would be 50. What would the next one be? Yeah, 51, because whole numbers are our counting numbers. We don't have decimals, we don't have fractions, so the first one would be 50, the next would be 51. And after that is 52, 53. Is it feasible to be able to write all that out? Well, yeah, so there's no real reason that we need to write this in set builder notation. We can, but it's just as easy just to write 50, 51, 52, 53, 54. So this one here is easier just to list the set than it is to write the full set builder. Because we can, because our inequality would be 50 is less than or equal to x is less than or equal to 54, because we're going from 50 to 54 and they're both included. And then we have to specify the set of all x in the whole numbers such that 50 is less than or equal to x is less than or equal to 54. I don't think that's any less complicated than this here. They're both the same. Are you ready for the next one? The set of real numbers 0 through 4. So what's the first real number from 0 to 4? 0, yes? Then the next one would be, because we do have 0, 1 and 2 would be in there, but do we have a lot of numbers between 0 and 1? Yeah, we have all the fraction answers, we have our rational, irrational. Is it doable to list all the numbers from 0 to 4? No, it's not even really doable to try to write all the numbers between 0 and 1, let alone 0 to 4. So this one here, because we can't just list all of them, we're going to have to use set builder notation to really list this out. Because our type, so we know for set builder, we're going to have brace x bar, the set of all real numbers x, such that we need to rewrite this statement here, this description 0 to 4. We know it's bounded because we do have two endpoints, 0 and 4, yes? Okay. And we know that x, our values that will work for this have to be between it. Now the question is, what are our inequality signs? We know 0 is going to be what? Less than or equal to x, which is going to be less than or equal to 4. Ready for the last one? The integers, -1,000, -100 through 100. Is it doable to write all these out? Because integers, we don't have the decimals. But our first one would be -100, yes? Then what? negative 99. Then negative 98 to the negative 97, negative 96, negative 95, negative 94. Is it doable to write all these out? I mean, it is. Would we want to write them out? No. That's going to be 201 numbers that we would have to list out. I think we have better things to do than to write out all the numbers from negative 100 to 100. So here, again, we're going to write this in set builder notation. Now, we don't necessarily have to put brace x bar. We can put brace x element of the integers. X is an element of the integers. X is a part of the integers for all real integers x, for all integers x, such that, what? Here, we've already written this once before, haven't we? And essentially the same thing as what we just did. Yep. That's it. Questions on this here? Be ready for the next problem. No problems. That's it. So that's the homework assignment. So 5 through 14, 17 through 24, 26, 27. So 5 and 6. Use brackets or brace to list the elements of the set. So 5 and 6, you're able to list them out for the most part. 5, you'll most likely use the ... because the set of integers greater than 50. So we do brace 51, 52, 53, 54, 55, 56, ... brace. Or if you want to put it in set builder notation, you can. 6 is similar to that. 7, 8, 9, 10, or 7 through 14, the rest of those, write the interval in interval notation. So that's our parentheses and brackets. We're just writing the interval there. The first 4 are in inequality form. We switch it from inequality to interval. 11 through 14, we're going from a graph to an interval notation, our parenthesis bracket. 17 through 24. Sketch the graph of each one of those there. Or 17 through 20, you're sketching the graph. And again, you can't, I would prefer you do this on a separate sheet of paper. But on 17 through 20, draw a number line, graph the section that is given to us. 21 through 24, write it in set builder notation like we've been doing today in class. 26, 27 is the exact same thing. And that's it. You have the rest of the hour to work on that. If you do have questions, please ask. But we're finished with section 1.1.